Hi, this video is the first of 3 on trigonometry intended for the ACT math exam. In this video, we're going to cover the basic triangle trig functions of sine, cosine, and tangent as how they relate to sides in a right triangle, also known as SohCahToa. We're also going to cover the reciprocal trigonometric functions being secant, cosecant, and cotangent. Then we're going to move back into the inverse trig functions used for finding angles inside of a right triangle. The description below has links to other videos if you want to learn further about any particular topic covered in this one. But for now, let's just get started on SohCahToa. SohCahToa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. What does that mean? Here you go. For a right triangle, and an angle right here, they usually put it right here. They could also put it up there. It doesn't really matter. You'll see. The side opposite that angle is the opposite angle. I'll call that one O. The hypotenuse is the one opposite the 90-degree angle. Always remember that through thinking of hippopotamus is really big, and this is going to be the longest side on a right triangle, and the hippopotamus is like hypotenuse. So anyway, that was just what I used. But anyway, the hypotenuse is opposite the right angle, and the adjacent is the one adjacent to the angle that's not the hypotenuse. Call that one A. Sine of theta is equal to opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, tan of theta, is equal to opposite over adjacent. Tangent is opposite over adjacent. One thing to keep in mind, these are functions, just like f of x, except these are special functions. They're not just generic functions like f of x or g of x or h of x. These are actually sine, cosine, tangent. They actually have meaning to them, but they are functions. You put in an input of an angle, and you output what this ratio is. Cool. Let's do some examples. What is sine of theta given an opposite side length of 4 and a hypotenuse of 5? By the way, pause the video if you need more time. Resume when you're done for anything covered in this video. Okay, you got it. All right, well, by definition, sine is opposite over hypotenuse. So sine of theta in this case is 4 over 5, which equals 0.8. Depending on what they want you to know, they may give you a bunch of decimals, says A, B, C, D, and E. They may give you fractions, I don't know. But either way, let's do another one. What is the cosine of theta given the side lengths here of adjacent side length of 8 and the hypotenuse of 15? Well, look at that. Cosine is adjacent over hypotenuse. So the cosine of theta is equal to, adjacent is 8, hypotenuse is 15, it's 8 over 15. Let's try one more. What is the tangent of theta? Tangent of theta is opposite over adjacent. Theta, the opposite side is 12, the adjacent side is 5. So that's equal to 12 over 5. Now, how would they do this on the ACT? They probably wouldn't say, hey, what's the tangent of the angle? Instead, they give you something like this. Given this triangle, which one of these is true? So it'd be something like that. In this case, well, cosine has to go over the hypotenuse, so that's out. Same thing with sine, that's out. There's no 13 in here. A tangent is opposite over adjacent. Yeah, there you go, done. But the point is, they give you something like this. They can give you a setup and say which one of these is true. Another setup they can give you is something like this. Find the side length x if this angle is 35 degrees. Give it a shot. In this case, the only sides we have access to are the opposite side and the adjacent side, so we're really looking at tangent here. So we have tangent of 35 equals opposite over adjacent, 12 over x. So, well, multiply both sides by x, get one on this side, 12 over tangent of 35 on that side. And then you'd plug that into your calculator and figure out what that is. 12 over tangent of 35. They may also say, well, what is x? And they give you a bunch of options. 12 over tangent of 35, 12 over cosine of 35, cosine of sine of 35 over 12, and all kinds of things like that. But if you can set it up yourself, you would figure out pretty quickly, oh, that's going to be 12 over tangent of 35. How about you try this one? Suppose they give you this setup, where you have theta, opposite side is x length, whatever x is. The adjacent side is 4x, whatever x is. And they want to know what the tangent is. Tangent of theta. Give it a shot. Well, again, as long as x isn't 0, this is just going to be x over 4x. X is canceled, again, as long as x isn't 0. And that's going to be equal 1/4. So tangent theta equals 1/4. Hopefully you remember the SohCahToa stuff. There's not much to it. So let's move on. Let's move on to one thing related to this that you need to know. That is, what is the definition of tangent? tangent of theta is the opposite side over the adjacent side, right? What if we multiply the top and bottom by 1 over hypotenuse? Then we'd have opposite over hypotenuse, that's a hypotenuse, over adjacent over hypotenuse. I mean, this is just multiplying top by 1 over hypotenuse. This is multiplying bottom by 1 over hypotenuse. You can multiply anything on the top and bottom by the same thing as long as it's the same thing, because that same thing is just 1. Multiply anything you want by 1, you're good. But what's opposite over hypotenuse? Sine. What's adjacent over hypotenuse? Cosine. Tangent of theta is sine theta over cosine theta. That comes in very handy. So given a problem like this, they give you cosine of theta is 0.6, sine of theta is 0.8. What's the tangent of theta? Suppose cosine of theta equals 0.5 and tangent of theta equals 1. What's the sine of theta? You give this one a shot. All right. Well, we know that tangent of theta, which is equal to 1, is equal to sine over cosine. And you know cosine of theta is 0.5. Sine over cosine is tangent. Let's just multiply both sides by 0.5. End up with 0.5 equals sine of theta. This is definitely one type of problem they could give you that's an offshoot of SohCahToa, where you have to know that tangent is sine over cosine. So know how to do it, and there you go. Let's do one more to drill this into our brains. Let's say cosine of theta is equal to 2 sine of theta. What is tangent of theta? Well, divide both sides by cosine of theta. So that way this becomes a 1. And now sine of theta over cosine of theta is tangent. So we have 1 equals 2 times tangent of theta. Divide both sides by 2 and you have tangent of theta equals 1/2. They could give you problems like these, that's all I'm saying. All right, let's move on to the reciprocal trigonometric functions. What are they? Secant, cosecant, and cotangent. How are they defined? Pretty simple, actually. Secant of theta, also abbreviated SEC, like secant, secant of theta is just 1 over cosine of theta. That's it. It also can be thought of as, since cosine of a right triangle is adjacent over hypotenuse, this would be hypotenuse over adjacent. It's just the reciprocal, the flip. Numerator and denominator shift places. That's it. Cosecant of theta is equal to 1 over sine of theta, which is also equal to hypotenuse over opposite. Since sine is opposite over hypotenuse, cosecant is the reciprocal of that, which is hypotenuse over opposite. That's it. Now I've seen cotangent abbreviated a couple different ways. It's usually cot, like cotangent, but I've also seen CTN, but I think that's kind of fallen out of favor back from my day. I think you guys will only see cot, so we'll go with cot. Cotangent of theta is equal to 1 over, can you guess? Tangent of theta. And since tangent is opposite over adjacent, what do you think this is? Adjacent over opposite. So just know those. Back in my day, when I first saw these, I was like, why isn't cosecant corresponding to cosine? You think that would be the case. It's not. Just know that they're the opposites. Secant corresponds to the cosine. Cosecant corresponds to the sine. It just is. Memorize it. Cotangent's the easy one. Cotangent and tangent. They're the only ones with tangent in them. But the when you're dealing with the reciprocal functions, it just corresponds to the regular. In this case, the cosecant corresponds to just sine. Cosine corresponds to just secant. So just know that that's the case, okay? Let's do a few problems with these. I'll leave these up here for now so you can reference them. We'll take them away in a little bit. Say we have that angle right there. What is the secant of theta? Pause the video if you need a second. Unpause when you're ready. Well, you know, cosine is 3 over 5. It's the adjacent over hypotenuse. So what's hypotenuse over adjacent? 5 over 3. So secant of theta is just 5 over 3. What do you think the cosecant is? Yeah, 5 over 4, because sine, it would be 4 over 5, the opposite over hypotenuse. So you have 4 over 5, so cosecant is going to be 5 over 4. How about cotangent? What's the cotangent of this one? Well, tangent was opposite over adjacent. Cotangent is adjacent over hypotenuse, which is 3 over 4. Tangent would be 4 over 3. Cotangent is going to be 3 over 4. They're just the reciprocals. That's it. It's not that bad. Let's do a few more. All right, I'm going to put theta up there this time. I'm going to do 30, 40, 50 instead of 3, 4, 5. So what is the secant of theta? Pause, resume when you're ready. Well, secant's 1 over cosine. Cosine would be 40 over 50, so this is going to be 50 over 40, which is 5 over 4. How about cosecant theta? What do you think? Well, again, cosecant is 1 over sine. Sine would be opposite over hypotenuse, so this is going to be hypotenuse over opposite, which is 5 over 3. 50 over 30 reduces to 5 over 3. And how about cotangent? Tangent would be 30 over 40, which is opposite over adjacent. Cotangent is adjacent over opposite, which is 4 over 3. 40 over 30 reduces to 4 over 3. Doing this kind of stuff should be pretty straightforward. If they ask for the cosecant of something, that should be in the first 20 problems. It should be a fairly simple problem. Literally, you could just plug it in your calculator if you had to, but you need to know the definition of cosecant, the definition of cotangent, the definition of secant. If you know the definitions, it's not hard at all. Here's another variation of the kind of things they could ask you when it comes to secants and cosecants and all that kind of stuff. What is sine of theta times the cosecant of theta? They give you a bunch of options, but just see if you can work it out. What is that? Go back to the definition of cosecant. This is sine of theta. What is cosecant? Cosecant is 1 over sine of theta. This is sine of theta divided by sine of theta, which is just 1. So sine times cosecant is just 1. How about cosine of theta times the secant of theta? Secant of theta is 1 over cosine. So that's just cosine over cosine, which is also just 1. How about tangent of theta times cotangent of theta? Same thing, it's just tangent times 1 over tangent, which is just 1. Those were the trivial ones. Let's move on to some that aren't so trivial. What's cosine of theta times cosecant of theta? Again, cosine of theta times 1 over sine of theta, which is equal to cosine of theta divided by sine of theta, which is equal to, drum roll, which is equal to cotangent of theta. Remember, sine over cosine is tangent. Cosine over sine is cotangent. Let's try another one. What's the sine of theta times the secant of theta? You probably see where this is going. This is sine of theta times 1 over cosine of theta, which is sine over cosine, which is tangent of theta. Let's do a really fun one. Try to reduce this one as much as possible. Tangent of theta times sine of theta times cosine of theta plus cotangent of theta times sine of theta times cosine of theta. Give it a shot. Well, tangent is sine of theta over cosine of theta, right? If you multiply that by sine of theta and cosine of theta, I can't draw. Cosines cancel, sine's squared. This is sine times sine. The shorthand for that is sine squared. That's a function shorthand, by the way. I'll touch on that here again shortly. Let's see, cotangent is cosine theta over sine theta. It's the opposite of tangent, times sine theta times cosine of theta. The sines cancel. You're left with the square. You have cosine times cosine, which is cosine squared. That's an S, cosine. So you have sine squared of theta plus cosine squared of theta, which is 1, always. If you didn't know that. Sine squared of theta plus cosine squared of theta is 1. We'll cover more on that in the next video when we cover unit circle. But for now, just know that's 1. All right, let me come back to this. If you ever have f of x and you want to square it, now you can just put parentheses around it and square it, but a shorthand for that for any function is usually just a 2 up top. And it's especially prevalent in the trigonometric functions. You see it all the time. When you see sine squared of x, that really is just sine of x, the whole thing squared. And you may think, why do you need the outside parentheses? Because then people will be confused, and if you're wondering if you're doing sine of x squared or is it sine squared of x, it's ambiguous. But if you put the square right next to the function, you're like, oh, you're taking the whole function value squared. So it's sine squared, the whole thing squared. So it's just a shorthand, but if you see that and you're not familiar with it, that's what they're doing. Anytime you have a function like cosine or sine or f of x or log or lots of things, you would just, if you see a square up there, that means you're squaring the whole thing. All right, let's move on to the inverse trig functions. These are sine inverse of x, cosine inverse of x, and tangent inverse of x. Now, if you remember, quick reminder, functions in general, you have a domain and you have a range. A function takes a number from the domain and maps it over here to the range. That's their function. So if x is over here, f of x will be over here. It's just a mapping, okay? An inverse function takes it back. F inverse, usually denoted with a power of -1, even though it's not really that. It's not 1 over. It's just an inverse function, which is, I know, it's weird shorthand, but mathematicians do weird things sometimes. But anyway, just know if you get there, if you get from the domain x to the range f of x through a function, you can get back with the inverse function. Okay? Just remember that. Now, so if you have sine of theta, let's say equals, I don't know, 4/5, like our 3, 4, 5 triangle. Okay? You can take the sine inverse of both sides. Remember, you can do anything you want to an equation as long as you do it to both sides. So I took the inverse sine of both sides. Sine inverse of sine, well, that's just taking a round trip. That's just theta. So now theta is equal to sine inverse of 4/5. And you can plug that into your calculator and figure out what that is. These functions are used to figure out what the actual angle is in a right triangle. As far as you're concerned for the ACT, that's all these functions are for finding the actual angle. If they give you side links, you can use those to find what the actual angle is. That's it. Let's go through some examples, shall we? All right, here you go. Nice triangle with the opposite length of the theta of 4, hypotenuse is 5. What's the angle? Give it a shot. Pause the video, resume when you're ready. All right, ready? Well, sine of theta is equal to 4 over 5. Opposite over hypotenuse, SohCahToa. So sine inverse of both sides, that would just leave you with theta on this side, and you end up with sine inverse of 4/5. Which, I plugged that in my calculator earlier, it's roughly 53 degrees. Like 53.13 degrees, something like that. You're going to get a decimal point in your calculator for this. Quick side note, make sure you not only know how to use your calculator, but have it set for degrees by default. They usually ask for things in degrees when they're asking for angles. Degrees are a lot more prevalent than radians on the ACT. If you move on and become a math major like moi, you'll see radians take over. During and after calculus, you don't see degrees again unless you're measuring temperature in physics or whatever. But you don't use degrees after that. But up until then, including the ACT, you're using degrees all the time, not radians. So get comfortable with degrees. This one's not necessarily drawn a scale, but this is a right triangle with a 4 and 6. What's the angle? Well, we have the adjacent side. So that means cosine of theta is equal to 4 over 6. It's also 2 over 3, but don't really care. In this case, you take cosine inverse of both sides. You end up with just theta on this side. You have cosine inverse of 4 over 6. Well, I'll call it 2 over 3. That's fine. And then you run that through your calculator, and that is roughly 48.19 degrees or thereabouts. By the way, in your calculator, if you haven't figured it out by now, sometimes they call the inverse functions arc functions. They can either have it fully spell out, arc cosine like that, or just be a cosine. Not sure what your calculator has, but know that these are the same thing. Arc cosine, a cosine, cosine inverse are all the same thing. Just like a sine and arc sine and sine inverse, they're all the same thing. Tangent inverse, a tan, arc tan, all the same thing. It's just some people call them different things. Yeah. All right, how about this one? What's theta? This is 12 and that's 13. All right. Sine of theta, because its sine is opposite over hypotenuse, SohCahToa. Sine of theta is equal to 12 over 13. Take the arc sine or a sine or sine inverse, doesn't matter. You pick one. Of both sides, you end up with theta equals sine inverse of 12 over 13, which is roughly, call it 67 degrees, I don't know, somewhere in there. Like 67.38, whatever, I don't care. Sometimes on the exam, they would just give you, hey, what is that angle? And they'd give you this as an option. They wouldn't even give you the number. Sometimes they give you the number, sometimes they give you the formula, and they try to confuse you with, is it the sine inverse of 12 over 13? Is it sine inverse of 13 over 12? Is it cosine inverse of 12 over 13? Cosine inverse of, they give you those kind of options. You just have to know, oh wait, that sine is this, and so you do the formula yourself, you can get it really quickly, just like I did over here. Then, oh yeah, theta's gonna be sine inverse of 12 over 13. And you can pick it out of a lineup pretty easily. What is the angle theta here? This is 8, that's 15. We have an opposite and adjacent side, so that's tangent. Tangent of theta is equal to 15 over 8. That's the opposite over the adjacent. So that means tangent inverse of both sides. You're going to put theta. It would be tangent inverse of 15 over 8, which is roughly whatever that is. I don't know, 61.93 degrees, somewhere in there. I don't know. Again, they may give you answers in terms of tangent inverse and cosine inverse and sine inverse. You have to pick one. They may give you actual angles. And usually I've noticed, a little side note, with the SAT, they'd usually have one or two that pop out at you as obvious. When you look at this angle's obviously got to be bigger than 45 degrees because this side's a lot bigger than 8, and this is the 90-degree angle right here. So it's going to be over that. So if they give you any that are below that, you can start doing the process of elimination. Even if you can't do the math, you can just common sense going, well, it's going to be, I don't know, 60-ish. But the SAT, they would do that. The ACT, they may not. They may give you, if they actually gave you these numbers, they may say 61.9, 61.8, 61.7, 61.6, and you're just sitting there going, ah, crap. So you need to know how to do it. Let's move on to some slightly more advanced problems, kind of combining lots of things. In this case, assume that theta is between 0 and 90 degrees, and cosine of theta is 3 times that of sine of theta. What is theta? Give it a shot. Well, cosine of theta is, meaning equals 3 times sine of theta. Well, I can do this a couple of different ways. I want sine over cosine because I have tangent. Then if we need to do a tangent inverse, we can. We don't usually have a cotangent inverse, but we have a tangent inverse. You might have a cotangent inverse on your calculator. I don't know. But I don't know if I do, so I'm going to go with just tangent. So let's divide both sides by 3. And let's divide both sides by cosine. And cosines cancel here, 3's cancel here. We're left with 1 over 3 equals sine over cosine, which is tangent of theta. Okay? This is a little arrow here. 1/3 equals tangent of theta, which means theta, if we take the tangent inverse of both sides, is equal to tangent inverse of 1/3. Plug that into your calculator. That is roughly 71.47 degrees. Now, here's a quick thing. Does that make sense? Well, if cosine is 3 times that of sine, if you drew the triangle, it would be something like that. This side over here, the adjacent side, has to be, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. You think this side has to be bigger if this is going to be 3 times that of this one. So why in the world am I getting a big angle and supposed to be a small angle? 3 times sine. I don't think I calculated it correctly. Sure enough, this is actually 18.44 degrees. I plugged it into my calculator wrong when I put this on paper before doing this whole thing. I'm glad I did the sanity check because I got it wrong. It happens sometimes. But at least my sanity check told me, wait a minute, if the cosine is 3 times as big as sine, that means this side has to be a lot bigger than that side, which means this angle is going to be a lot smaller than 45 degrees. There's no way it could be 70-something. So that's where your sanity check comes in. Let's try another one. Let's say I have a right triangle. This side is 5. This angle is 35 degrees. What is, I don't know, what is this side length? Give it a shot. Well, sine of 35 is going to be equal to this side over 5. So it's x over 5, which means x is going to be equal to 5 times sine of 35. I just multiply both sides by 5. That's all. So what is sine of 35 times 5? Plug it into your calculator. Roughly 2.87. I don't know, you got a 5-foot board, you're making a ramp, you want it to be 35 degrees. How high is it going to be? It's going to be 2.87 feet off the ground. Let's do one last problem. What if secant of theta is half that of cosecant of theta? What is theta? Secant is half of cosecant. Give it a shot. Well, I'm going to rewrite this in terms of sines and cosines. Secant is 1 over cosine. And half, this is 1 over sine. And if I can put the sine up here, then I have sine over cosine. That's tangent. So I'm going to say that's tangent. Theta is equal to 1/2. So that means theta is equal to tangent inverse of 1/2. My marker's dying. I apologize for that. Plug in tangent inverse of 1/2 in your calculator, and you get roughly 26.57 degrees. That's about it in terms of what you need to know from this stuff. Just get a lot more practicing, get a lot more familiar with it. Know your SohCahToa like the back of your hand. Know the reciprocal trig functions. Know that secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent. No tangent is sine over cosine. No cotangent then is cosine over sine. Know that sine squared plus cosine squared of the same thing is 1. And know how to get the angle by just applying the inverse function at both sides. That's it for this video. See you in the next one. Until then, hope this helps.